Hi guys, welcome back. In this episode of Vaccinate India, we will be learning about the many strains and mutations of the virus, how infectious they are, how they've mutated to what they've become, and what we know about the effectiveness of the vaccines against these new strains and mutations.
Thanks, Alia. And to help us understand this further, we will be speaking with Professor Ravi Gupta. He is the Professor of Microbiology, Department of Medicine, University of Cambridge. He was also named one of Time magazine's 100 most influential people in 2020. Professor Gupta has been leading the research into emerging variants, especially in India and the UK. And he's also studying the efficacy of current bouquet of vaccines against these emerging variants. So let's find out more about this from Professor Gupta. So why is this COVID virus mutating so fast? Or is this a normal thing that viruses do? And what is the purpose of it?
We looked at the ancestors of SARS and its relatives, and we said, okay, well, these viruses mutate, but not that much. In the early days, and we saw, yeah, we're right, we're correct. The virus is not mutating much, and it's this is as we expected, and it's a bit less than flu even. But then what happened is that we realized that some people were getting chronic infections. So some individuals out there whose immune systems are not quite working correctly, they become infected and they can't shake off the virus. And what it does is it kind of stays inside them. It starts making more. And then the immune system, which takes about 7 to 10 days to start working, throwing out antibodies at the virus. And then the virus, because it's reached quite high levels in these people, is not suppressed properly by that immune response. And then it starts selecting for mutations, which are enabling it to get around those antibodies. So when you put a pressure on something, one option is to get around it, or the other way is just to drive through it quicker. So the virus is driving through these barriers quicker, and it is trying to get around them by changing the shape of its proteins so that the antibodies are not binding or recognizing the virus anymore. That's what's happening to accelerate evolution of coronavirus. And then when that person infects many others, they all then start passing on that new virus. And that's the birth of a new variant.
Obviously, there's a very strong pressure when we are doing global vaccination on a virus like this. And has this been seen in past vaccination drives that when you put a strong pressure like this, they will try to escape it?
It's not as easy for viruses to get around vaccines as we may think, because the vaccines make many different responses. And, we have a really broad array, an armamentarium or army of immune responses, and viruses will find it very difficult to escape all of them. So there are very few examples where vaccines have failed because of resistant viruses. I mean, the only example of this happening is where HIV is so diverse and it makes so many different changes that our vaccines are unable to cope with all of these differences. So this is not a common phenomenon.
So what you mean is that the antibodies that we get, if we look at them like Lego pieces, it's not just one Lego piece that the antibody is shaped like, there are various ones.
That's right. Yeah.
Okay. In India, of course, we have seen these new mutants, which is called the double mutant, triple mutant, using the numbers and alphabets that are associated with these variants is not very, let's say, layperson friendly. What should we be calling them? Is this the right way to describe the mutant?
I mean, at the end of the day, it's about communication, and communicating it in a way that people understand is important, because what would happen is if we used complex numbers all the time, people would just lose interest. And I think that it potentially is negative, because then misinformation can spread, because people will want to go to the easiest source, and that may not necessarily be scientific. Many of us use the country names from which where the big epidemics are happening, where the virus originated. I try and use both names, the number plus where it sort of emerged from, so that people can understand what we're talking about. At the end of the day, everybody's going to have a variant, and I personally don't think it's a stigma problem anymore, because every country has a variant, and we all have one. So I don't know why people are getting so upset now, especially as there's one in the Philippines, there's the UK, there's rich countries, poor countries who have their own variants. So I think this will just blow over, and we should just use the terminology that we can understand. I don't think we're going to come up with some system magically that everyone can understand and is implemented universally. I think we should stick with what we have, because people don't have infinite energy to understand this.
But just to clarify, if you're saying there's a triple mutant versus a double mutant, the triple mutant is not necessarily.
Oh yeah, those words are not helpful at all, because those are not very descriptive terms.
So I understand that you have specifically studied the variants from India versus other variants. Could you tell us what is the state of knowledge?
For virulence, it's hard to guess because that's basically saying that if you're infected, you're more likely to get really sick. And that is really hard to measure because you need to compare it with something else in the same population at the same time. These guys did worse, these guys did better. That's going to be really hard to figure out. Now, transmissibility is also hard because transmissibility, if you boil it down to what it means, it's actually how easily is it passed from one person to the other. And that depends on partial immunity and vaccination as well, right? Because if you're vaccinated, the transmissibility will appear to be very low. In fact, if you're fully vaccinated and the virus can't get around you, that's a zero transmissibility. So the virus still has transmission potential. It's just that it can't get over the defenses in the person. So when B117 was described back in December, the background immunity rates or previous infection rate in people in the UK was only 10% or something from the first wave. So there we talked about transmissibility because the B117 was then going into populations that were largely non-vaccinated and had never seen the virus. So you could measure it quite accurately. It's much more difficult now with all the waves of infections we've had globally.
Just wanted to ask you about the 0.2 variant in India, which is infecting those who have had the disease before or even those who have been vaccinated. Is this of concern, and how worried should we be about this?
This is the main issue with the 0.2 variant, in that there were numerous reports in India of vaccinated people being infected, usually with mild symptoms. So we're not going to say that this is a really terrible issue, but people who have been vaccinated are being infected despite vaccination. There's an outbreak in a healthcare facility where at least 10 people were infected by a single virus, as it were. And they were all fully vaccinated. So they'd all had at least the 2 doses well before the incident. So they should have had very high levels of immunity, and yet they got infected. Most were, but they all had symptoms, which is why they were tested. So they were sick enough or symptomatic enough to want to be tested. Some felt very, very ill, but none of them were hospitalized for very long. They did not have severe disease.
Vaccine companies are also now testing their efficacies in new populations against new variants. From a country point of view, does this mean that countries should look into changing their vaccination profile?
This is going to be a difficult problem for some years to come. Many different vaccines, variable efficacy. We have new variants all the time. It's going to require people to fund science properly. Some really fundamental research, not only on this particular virus, but its ancestors, aspects of its biology we can manipulate to give wide-ranging protection with vaccines. Because if you imagine, if we detected a coronavirus now, if we had the right tools, we could send all of our vaccines to stockpile, we could send it to that country or that place, vaccinate everybody around, stop it spreading.
So would you say that countries need not stockpile and actually hedge against having more distributed profile of vaccines? Is that a smarter choice?
Countries are in a difficult position now. One way of doing that is closing the borders and vaccinating everybody. So that's the obvious thing, which is what most people in the street would want that from their government. So the problem with this disease is it happens in big hotspots. So you probably want to target the hotspots and prevent spread. And that's the way that vaccines probably should be used in a targeted sense. But that's a really difficult thing because it requires excellent surveillance, genomics, it requires interlinkage, it requires real-time decision-making. So that's the way that vaccines should ideally be used, as a tool to put out fires, obviously prevent the fire in the first place, but once they're little burning embers, extinguish them quickly. Because, of course, we don't have enough vaccine to just blanket vaccinate the whole world immediately, which is obviously the ideal thing.
Is it prudent to even imagine that they will not escape? Variants are going to cross country borders. We are looking at the next 20 years of global vaccination then.
The virus is unlikely to go extinct. Let's put it that way. It's probably now here to stay. It's going to be, you can't wipe this out. And so we'll have to start living with it, just like influenza and all that we deal with. And with good vaccines, we should protect most people against becoming really ill. That would be the ideal situation. So that's the way to look at this.
Thank you, Professor Gupta.
All right. Thank you too. Take care. Bye.
Bye.
Thank you so much for watching. If you found this video helpful, then please like, share and subscribe. Please take care and stay safe.